So loop of Henle. Loop of Henle is a U-shaped tube. They have simple squamous epithelium instead of the simple cuboidal epithelium. The simple squamous epithelium, which makes the cell even thinner, and it facilitates the we call it reabsorption of water, meaning that reabsorption of water occurs in here, meaning that the water will go from the loop of Henle, which is part of the kidney tubule, into the blood, going back to the blood, going back to the peritubular network, peritubular capillary network. It will go back to your blood. So this loop of Henle is for reabsorption of the blood. And then after loop of Henle, you have distal convoluted tubule, DCT. Again, it is made up of a simple cuboidal epithelium. And then it has more mitochondria, but lack of microvilli. The reason is that you have mitochondria here because you have lots of active transport occurring in there. It is designed for tubular excretion rather than reabsorption. Tubular excretion, meaning that, for example, the medication or the drug that you take, excessive, if you, for example, you take Tylenol, not all the Tylenol will be absorbed in your body. Excessive of the Tylenol, extra Tylenol, they will be excreted in this DCT area. And then excretion of the drug, meaning that from the blood to go into your DCT, that is active transport that requires mitochondria to produce energy to do so. And then, of course, multiple DCT connect together to form the collecting ducts. So let's take a look. This is the loop of Henle for water reabsorption. That means water will go from inside this loop of Henle to go into the peritubular capillary network, the blood vessels here. And then this is the distal convoluted tubule for drug secretion and secretion of drug and also other ion and metabolic waste. So this is the actual picture how it looks like. The efferent and afferent. You can see that the afferent arteriole is indeed larger in diameter than the efferent arteriole. So that you will create a positive pressure in the glomerulus, which is a network of capillary. And the output of the efferent arteriole, they form the peritubular capillary network. So this is the histology slides. You can see that distal convoluted tubule, they are made up of a simple cuboidal cell, one layer of cuboidal cell. The proximal is not very clear to see the simple cuboidal cell. And then this is the glomerular capsule or Bowman capsule. The surround this is the glomerulus or glomerular capillaries. This one, again, you can see the ascending limb and descending limb theoretically should be able to simple squamous cell. But they look more like a cuboidal cell in here. Collecting duct, it is also by the cuboidal cell. Urine formation. Okay, now this is the physiology of the the urinary system. Is how do we form a urine? We have 3-step glomerular filtration. As the name suggested, it occurs in the glomerulus. It is basically what happened between the glomerulus and the Bowman capsule or the glomerular capsule. Then you have tubular reabsorption that occur in the proximal convoluted tubule and also the loop of Henle. tubular secretion in the distal convoluted tubule and the collecting ducts. So you can see that it is color-coded. Okay, glomerular filtration occurs in here from the capillary, glomerulus, into the Bowman capsule. You can see an enlargement here, the magnification picture. Water, urea, glucose, amino acid, uric acid, and salt. All these go into the Bowman capsule, so that you go through all these kidney tubule, and you do not see protein. You do not see blood cell. You do not see protein and cell go into the Bowman capsule because if you look at this picture carefully, you can see the podocyte is drawn on the surface of the glomerulus. Originally, this is a blood vessel, pure red. And then here you can see that it looks kind of white, pale color because the artist drew the podocyte on the surface of the blood vessels here. That's why it becomes kind of a pale or white. You can also see the feet of the podocyte here because of the feet of the podocyte that wrap around the capillary, so that the larger molecule like protein and also the cell, the blood cell, they cannot go through the capillary into the Bowman capsule. And after this, you go to the proximal convoluted tubule. You can see that it is colored in blue, green and blue. Green, you have the reabsorption occur. Blue, you have secretion occur. And then you go through a loop of Henle, mostly for reabsorption of water. And then now you go to the distal convoluted tubule, you also have reabsorption and secretion occur. Glomerular filtration. Now we talk about the first step of production of urine. When the blood enters the afferent arteriole and the glomerulus. Okay, blood pressure forces water and small molecule to go into glomerular capsule. This is what we call filtration. What does it mean, blood pressure? I mentioned before the afferent arteriole has a larger diameter. But the exit of the glomerulus is the efferent arteriole, which has smaller diameter that create a positive pressure. This is what it means, the positive blood pressure here. Forces water and smaller molecule to go into the Bowman capsule. Therefore, we call this filtration. Larger molecule and form element cannot leave the capillary. Large molecule, for example, protein. Form element, for example, blood cells, they cannot go through the capillaries. So the filtrate, glomerular filtrate, that means the solution and substances that go into the Bowman capsule. They have small dissolved molecule. Their concentration is very similar to the plasma. And unfiltered molecule, for example, protein component, the blood cell, they will leave the glomerulus through the efferent arteriole. So this is a table that's good to know. You have the water that can go into the Bowman capsule, nitrogenous waste like urea, ammonium, uric acid, all this go into the Bowman capsule. Nutrient, what does it mean, nutrient? Nutrient means glucose and amino acid. These are the nutrients. Also go into your Bowman capsule. Salt and ion, for example, sodium chloride, they also go into your Bowman capsule. Okay, what does not go into your Bowman capsule? Blood cells and platelet cells. Red blood cell, white blood cell, and platelet cell, all these, they do not go into the Bowman capsule. And most importantly, proteins. All the proteins should stay in your blood. So glomerular filtration, our kidney filter about 180 liters of water per day, okay? Well, you may think, well, we filter that much, but I don't, every day when I go to urination, when I go to pee, I don't get that much of the urine. Okay, the truth is that yes, the nephron or the glomerulus, they do this amount 180 liters per day, but our body reabsorbs most of the water. Yes, our body reabsorbs most of the water back to the capillaries. So you can see that we filter 180 liter of water, and then we only excrete approximately 1% of the water because we reabsorb approximately 99% of the water back to our body. Sodium from our salt, it is almost the same. We absorb 99.5% of the salt. Remember I told you in the first video, this is the principle. Our kidney control the reabsorption of the sodium. So we absorb most of the sodium, so that water will follow the sodium, the concentration of the blood, and then by osmosis, water will go from your nephron back to your blood vessel, so it is by osmosis. And then glucose, again, it is not just 99%, it is 100%. 100% will reabsorb so that you don't have any glucose secreted in the urine, because if you have glucose secreted in the urine, that means you are diabetics. And then urea, which is a metabolic waste, you can see that only 44% of the urea is being absorbed. Why is that? We will talk about this later. This is a very interesting question that I asked my physiology student. Urea is a metabolic waste. How come we don't have 100% of secretion of urea? How come we only secrete maybe less than half of the urea we secrete? Why do we keep half of the urea in our body? So we'll talk about this later. You can think about it right now, and we'll talk about this. We'll explain this later.